All right, we're still on 10.3. Yesterday we talked about shape. Today we're going to talk about center, and then tomorrow we're going to talk about spread. Center, how do you find numbers that are kind of in the middle? One number that summarizes all the data. So shape looks at all the data. What does it look like? Where are the points? Are they in the middle? Are they on the outside? Now, can we find one number to summarize it all? So the mean, how it's found, I think you guys know. You take the sum and you divide by the number of elements. So add them up, divide by how many there are. You guys have been taking an average, whatever, since first grade. Here's what it tells you. What it tells you is if you add up all the if you add up all the data points and divide them up evenly, so it's an even distribution. Of data. So if we're talking about maybe average income, what this would do would take everybody's income, divide it by how many people there are, and divide it evenly amongst everybody. So it just would take your data and just distribute it evenly. What's really nice about taking the mean is it uses all data points. It uses all data points. So everything gets to have a say when finding the mean. You're going to add up all the numbers and divide by how many there are. The problem with an average is that outliers have a big impact. Outliers have a big impact. Well, I think you know what I mean, but just in case we're all clear, if I'm adding up some numbers and 1 plus 2 plus 3, and I want to take the average of those three numbers, well, hopefully we're clear, it's going to be 2. But the moment you add like an outlier, like 1 million, 1, 2, 3, and divide by 4, well, these numbers are all small, and this one big number dragged the mean up to 250,000 something. So sometimes if there's a really, really big number or really small, it can have too big of an impact on the data. Okay, in that case, what you want to do is use the mean. How do you find it? It's the number in the middle. What it tells you, the middle number. Okay, the advantage of it is exactly what the mean doesn't do for you. I'm trying to get this to focus. What the mean doesn't do. The advantage is it's not affected by outliers. Not affected by outliers. Okay, so if I was going to do this data, the median of this one on my calculator, the median is 2. If I put this huge number, well, the median is now 2.5. So, it affected a little, but it did not have a huge effect like it did on the average. So outliers have less of an impact. The shortfall of it is all it tells you is the middle number. Okay, so it really doesn't say much. Let's just say it doesn't use all data points. It doesn't say much about the ones that are on the outsides. Your really big numbers and your really small numbers, you really don't know much about it. All you know is the number in the middle. These two as a pair are actually really, really helpful. Okay, they're really helpful because the mean, you can say, hey, here's a number that takes all the data points into account. The median, here's the middle number, and if those two are pretty, if those two numbers are pretty close to one another, you can have a pretty good statistic. The mode is probably the least effective from all of them. How it's found is which one occurs the most often, and I don't mean, it's not the most like the maximum, but occurs the most often. What it tells you is that the element that occurs most often, oh boy, occurs 2 C's, 1 R, most. Okay. Really, I mean, the advantage of it, you can see numbers that show up a lot. Numbers that show up often are recorded. That's about it. I mean, trying to think about a good time when the mode is going to be used. I mean, my wife has a sign business, and so if there was one sign that was selling a lot, I guess it would be nice to know which one of our signs sells the most often. Which one is our mode? I guess that would be nice, but for most data sets, it's really not that helpful at all. And then the shortfall, hopefully, is pretty obvious. I mean, it really only tells you about one specific data point. Only tells you about one data point. The rest of it is pretty much left out. If everything in the whole data set occurs once and one happens to repeat, so it happens twice, there's your mode. So, it doesn't necessarily tell you that much. But these three together can be a nice statistics. You got your mean, your median, and your mode. Finding these are not difficult, so let's get into some of the tricky parts of the mean. So I'll try one or two of these examples and let you try the rest. So we have a mean question. Gene's a biologist and has taken 3 biology tests and has an average of 83%. What does he have to score on the 4th test to bring his average up to 85%? All right, I'm going to solve this one way. Some of you will find a shortcut. Of course, when you find it, go ahead and use it, and I'm good with that. First of all, let's forget about the 4th test. And if I have 3 tests, here's what I know. When I take these tests, I'm going to add them up. And when I add them up, I'm going to divide by 3 and get 83. Okay? So I'm going to take 3 tests and add them up, divide by 3, and get 83. Now, excuse me, what is the value of each individual test? That actually doesn't matter. All I really need to know is the sum. So when I put X up here, X is going to stand for the sum of those 3 tests. So were they all 83s? Maybe. But no matter what, if they have an average of an 83, the sum of those 3 tests will always be the same number. So I'm going to multiply by 3, go 83 times 3, and get a sum of 249. So I know that X is going to be equal to 249. So do I know his tests? No, but I do know that Gene so far has 249 points. So here's what's going to happen. I'm going to take those 249 points. I'm going to take another test. I've already used X, so let's just call it Y. I'm going to take one more test. Now I'm going to divide by 4. So, because I'll have a 4th test, and I want my average to be an 85. So let's see if we solve that problem. We should be able to figure out what it's got to be. I'm going to go times 4. 85 times 4, get 340. So 249 plus Y is going to be equal to 340. Minus 249 and get 91. So Y is going to be equal to 91. So a score of 91 will bring that average up to an 85. All right, after that we have what's called a weighted average. This is used actually all the time in school. So in your classes, 9-week, I should switch that semester grade. We don't have 9-week grades anymore. So maybe a class might do this. Tests are 60%, quizzes 20, homework 5%, labs 15, and then it gives you your scores on each one. Well, if this were a straight average, you would go this plus this plus this. You'd add up those 4 numbers, and you would divide by 4. So add them up, divide by how many there are. But it is a weighted average. There's 2 ways to do it. So I'll show you both ways. This is probably, this is the way I would do it. So we're going to take our score of 78 on tests, and let's multiply by its weight, which is 60%, so 0.6. Plus, we'll take our score on quizzes, which is 65, and multiply by its weight, which is 0.2. Plus, we'll take a score of homework, which is 90, and multiply by its weight, which is 0.05. Plus, and then we're going to go 86, multiplied by its weight, which is 0.15, and then add that all up, and you should have it. So let's give it a try. 78 times 0.6 plus 65 times 0.2 plus 90 times 0.05, 0.05 plus 86 times 0.15, and you've got your 77.2. Okay, that's the way I call it using the weights. Now, another way that we could do this is we could write it out, and hopefully I left myself enough room here, is we could write it out. We'd say, instead of dividing each number by 100, we could say, all right, we're going to take our score of 78 and give it a weight of 60. Plus, I call this the fraction way. So 78 times 60 plus our score of 65, and we'll weigh it in there, times 20, plus our score of 90, and we'll weigh it in there, times 5, plus our score of 86, and multiply it in there 15 times. And when we're done, we'll divide everything by 100 because it's all 100%. So you can see this math is similar, but just a different way of thinking about it. You get the exact same answer. All right, pause it, try the other three, and then we'll call it a day. All right, two ways I can think of this is driving 70 miles per hour, and I can do it for, let's see, how many total? Let's look, there's 50, 63 minutes. So I did that for 50 63rds of my trip. Plus I can drive 35 miles per hour. And I'm going to do that for 10 63rds of my trip. Plus I'm going to go 25 miles per hour. And I'm going to do that for 3 63rds of my trip. And that would be very similar. Instead decimals or fractions is the same idea. Okay, so this is one way that we could solve it. So we're going to go 70 times 50 divided by 63 plus 35 times 10 divided by 63 plus 25 times 3 divided by 63, and we'll get an average of 62.3 miles per hour. If you don't like that way, another way that we could do it is we could take 70 and we could multiply it in there 50 times. Plus 35 and multiply it in there 10 times, plus 25 and multiply it in there 3 times, and then divide it all by the total number of minutes, which is 63. Both of those ways give you the same answer. All right, in an algebra class of 20 students, the mean grade was 82, and another with 30 students, the mean grade was 72. What would be the average of all the students? Okay, so one grade was an 82, and let's see, it looks like we had 20 50ths of the students got that. Plus, we had a mean grade of 72, and it looks like, let's see, I guess it would be 30 50ths. So we could do it with the fraction way. We'll go 82 times 20 divided by 50 plus 72 times 30 divided by 50, and we'd have 76 for an average score of all the students. If you don't like that way, we can say, hey, let's take that 82, and let's multiply it in there 20 times, plus 72. We can multiply it in there 30 times and divide it all by 50, because that'd be the total number of students. All right, last one. This one's tricky. Depends on how you think about it, because we have this gambler, and for a particular raffle, each person is paying $5 for their ticket. So the first person will win. There's going to be one person who wins $300, but you have to be careful because they don't win $300 because they paid $5. Okay, 5 people will win $50, but they didn't win that. They actually only won $45. 10 people will win $5, but they're actually not. They're going to win 0 because they're going to break even. And then you have 184 people who win 0, but they actually don't win 0. They lose $5. Okay, so we're going to take each outcome, each thing, and we're going to multiply it by its weight. Okay, so if we have this, there's a couple different ways that we can do this. The first thing that we have is we have $295. Like I said, you're going to win 300, but you're going to lose 5 paying for it. So they win $295, and we're going to multiply that times the 1/200th. Right there, we're going to put it in there one time because only one person will win that. Plus, we'll take the next one. It's not $55, it's $45, and we're going to multiply it by its weight, and that's going to be 5/200ths. Plus, the next one, 10 people will win 0. We'll go, I don't really need to write it, but 0 times 10/200ths plus 184 wins 0. That's actually going to be the outcome is -5, and that will be at a weight of 184/200. Okay, so we want to know what's the average per ticket winning, meaning if you went and bought all the tickets and then averaged out how much you won per ticket, what are you going to win? So we'll go 295 times 1 divided by 200 plus 45 times 5 divided by 200 plus 0, I'm not even going to write it. And we'll go minus 5 times 184 divided by 200, and you've got negative $2. So negative 2 means if you bought all the tickets, you would, per ticket, you would make negative $2 per ticket. That's on the winning side. Now, if you're running the raffle, if you're the people running the raffle, that means on this thing, you are going to make $2 on every single ticket. Of course, we could do this one. Go 295 times 1 plus 45 times 5 plus 0 times 10 plus negative 5 times 184. Everything divided by 200. That would work as well. So weighted average is probably the trickiest part of this section.